In this video, I'm going to talk about the question from Cracking the Code interview. This is the fourth question in Chapter 10. So first, let me briefly introduce this problem. So given an array-like data structure, I call it Listy. So this data structure has no size. That means we cannot know the length of this array-like data structure, but we can use get method to get a certain value at a certain index if the index is larger than the length of this data structure. This method will return -1. So the aim of this problem is to search a target value in a sorted list. So how to solve this problem? First, naively, we can compare the elements inside Listy one by one to the target value. Compare one by one is the naive method. The time complexity of this approach is Ln, where n is the index of the target value, or if we cannot find it, it should be the length of this array-like data structure. So we can see that this problem is very similar to the typical binary search problem. For a binary search problem, first we know the range of target value, and we can cut this range in the middle, and then we compare the mid value to the target value, and we can decide which half to search in the next round. And in the end, we can find the value or cannot find it. So the main problem in this data structure is that we don't know the length. That means we don't know the range. This is the main problem. So how to solve this part? So briefly, if we can find the range, and then we can apply binary search to find it. So for the first step, find the range. The approach, I name it doubly search. So let me explain this. So in the beginning, I search the range. I suppose that the target is inside the range index 0 to index 1. Here is the index. So the lower index 0 and the higher index is 1. So I compare the value at compare the value at high to the target value. So if the target value is larger than the target, that means the target value should be inside this range. Should be in zero, between 0 and 1. So if the target value, so if the value at high index is less than the target value, we need to continue to search, right? So at this time, and right now, I need to double this range to 1 to 2. Okay, to 1 to 2. So similarly, if the value at high index is at 2 is still less than target, and then we double it to 4. If the value at 4 is still less than target, we double it to 8. So every time we double the range. So at first is 1, at first. So here is 1, here is 2, here is 4. So each time, if the target value is not inside the supposed range, we double it. So if there's another situation that the value at high index is equals to -1, that means it's longer than the length of the data structure. So that still means that the same as we found the boundary, we found the higher boundary. So if we found the higher boundary, that means we can search in the range like k to 2k. Here, this 2k is less than 2n. Sorry, less than 2n. If this n is the index of the target value, and k should be less than n. So the next part is to do the boundary search. Okay. So let's talk about the time complexity. So first step, with one searching the range, we need log n to get the range, and the boundary search still log n to get answer. So totally, the time complexity should be O log n. Apparently is much better than ON if we compare to the naive approach. Okay, let's do a brief summary. So the aim of this problem is to search a target value in the sorted array without size, without the known size. Okay. So first we need to find the range. we use double search. Second, after we find a range, we use binary search. And the time complexity is O log n, where n is the index of the target value. Okay, so that's it.